What's up, everyone? Sam here from byte.com, and today I wanted to talk about something that I think will be really helpful for you as you're going through your coding interview prep. And this is a question that I got from one of my students recently. He said, I found an exercise to clone a graph, and every solution I found uses recursion. Is it worth trying to solve this iteratively? And I thought this was a really interesting question, and I kind of wanted to break down some of the thought process behind this because it's not so much about answering this particular question, but thinking about how you're preparing for your interviews in general. So, what I said to him about this particular question was I think it is worth it to try and solve this both iteratively and recursively. Are you ever going to solve it iteratively in an interview? Probably not, right? There's a reason why most people are likely doing it recursively right now, and it's probably because that's a lot easier than doing it iteratively. I've not personally tried to do this myself, so I'm not sure off the top of my head, but I would guess that, the recursive, like depth first approach is probably the way that I would do it. That being said, why should you approach it iteratively? Why should you try doing this other thing? I think that so often when we are preparing for our interviews, what we tend to do is we tend to say, okay, here's a problem. What is the ideal solution to this problem? How do I get from where I am right now? How do I get from that problem definition to the solution? And that makes sense logically, because logically, when we're in our interview, we want to come up with what is the best solution to this problem. But in reality, the problem with that is that we never really learn much about the underlying data structure, the underlying algorithm, the underlying things that we are actually trying to learn that are going to get us to that next level of interviewing. So let's think about this for a second. Imagine that you are traversing a tree, for example, and you decide to do depth first search. And what you realize when you do that is if once you sort of understand how depth first search works, and once you sort of understand that process, you apply the same things every time, and it becomes almost rote. It becomes this thing where you're no longer thinking about what it is that you're doing. You're thinking about how do I, what are the steps that I know to do because I have done this so many times. And that's one of the reasons why a great exercise that you can do, for example, is to write all these different traversals of trees. So you can do a post-order traversal, you can do a pre-order traversal, you can do an in-order traversal, you can do a level order traversal. And by doing that, what it forces you to think about is not just how do I do this one thing, but you have to actually understand what you are doing, right? Because it's not possible for you to just go and say, yes, you can just tweak stuff and kind of see what works. But in reality, the best way to actually do this is to really understand how does a tree work at a deep level. Another problem that I came across recently that I was actually just recording a video on today is this problem on LeetCode I think it's called merge binary trees. And the idea of this problem is that you have two sort of partial binary trees and you want to basically layer them on top of each other. And so what that means is that there are some nodes that are going to overlap and some that are not. And the nodes that overlap, the resulting tree should be like the sum of those two nodes. And then the other nodes are just filling in the tree. And why I think this is an awesome problem, it's not a super hard problem. But what it forces you to do is it forces you to say, okay, let me take my existing knowledge of trees. Let me take my understanding of how this process works, of how I do these things, and apply them in a situation that I'm not used to. I can't just say, okay, I'm going to do this rote thing that I already know how to do with depth first search, with breadth first search, just apply that and get a result. And that's what we do so often when we see these problems is we just apply that same strategy that we already know rather than actually digging in and trying to understand what it is that we want to do. Right? So this is how I want you to start thinking about when you're doing your interview prep. Is there a way that you can say, maybe let me solve this problem in an unconventional manner? Is there a way that I can use this as a foundation for me to learn more deeply what it is that I need to know about this data structure, about these algorithms, right? Because it's going to allow you to go from your basic understanding of, I know how to implement depth first search, right? Implementing depth first search at a basic level, super simple. But do you really know what's going on under the hood? Do you really know what's going to happen when you tweak the different variables there? If you tweak the order of operations when you are doing your recursion, what effect does that have on the result? So I thought this was a really interesting question. I just wanted to share this with you guys today. Not anything beyond that. Just I think this is a really valuable way for you to think about learning data structures on a deeper level. Getting deeper into the nitty gritty and understanding. You really want to understand like how is the data structured and how does that affect the way that I then access the data and then I can then use it in my algorithms. So with that, that's all I got for you today. If you enjoyed this video, definitely go over to bytebybyte.com/50 questions and check out our free 50 coding interview questions guide. We have 50 common coding interview questions in there with video walkthroughs of all that. It's a super useful guide. We've had, I think, more than 10,000 people download it at this point. So definitely go check that out. Appreciate you joining me today, and I look forward to seeing you in the next video.